Hello everyone. In this video, we will be discussing CS1 paper B 2022, September 2022 paper. The solutions are true to the best of my knowledge, and there is possibility that there might be some errors, or it might not match or with the examiner report when it comes out. So till now, these are the best to the best of my knowledge. If there are any issues, you all can post it in the comment section. Let's start with the first question. A systems actuary is developing an automated application to replace a time-consuming manual process. It is assumed that the number of errors X under this automated application process follows a Poisson distribution mean 6. The actuary wants to perform an analysis on the error rate for the automated process using the sample mean X bar. Use the command set.c 2022 to initialize the random number generator. So that's a very normal and easy thing that we just need to set the seed to 2022 so get our answer. Then determine an estimate for the mean and variance of the sample mean X bar by implementing 5,000 Monte Carlo repetitions, each involving a sample size of 150 from the assumed Poisson distribution. So we have to take 5,000 and lambda is given to us as 6 because mean and variance of Poisson distribution are same. X bar, we created an array. We'll create an empty array with 5,000 length. And then we'll do a loop for I in 1:1 length of X bar. We have X as our poise of 150 comma lambda because N is supposed to be 150. And then X bar I is nothing but mean of X. Okay. So basically I'll just run this. Okay. And then we have mean of X bar and variance of X bar as told to calculate in the question. Okay, determine an estimate for the mean and variance of X bar. Then the actuary recall that a normal approximation can be used by referring to the central limit theorem. So now we have to approximate to the central limit theorem, write down the approximate distribution of X bar using central limit theorem. So for a central limit theorem for a Poisson distribution, it is mu comma sigma square by n. Okay, where mu is 6, that is lambda, and sigma square is again 6 by n, which is 150. So we have 6 by 150, which gives us normal 6 comma 0.04. Then compare the approximation in part 2 with your answer in part 1. So if you can see, the mean is approximately same and the variance is also approximately same. So yes, our distributions match. The actuary wants to justify using the normal approximation by comparing all quantiles in one go of X bar and the normal distribution using a QQ plot. So we need to create a QQ plot for X bar and the normal distribution using Monte Carlo X bar values. So we can just do a QQ norm of X bar, and then this creates a theoretical quantiles and sample quantiles with a normal QQ plot. This is of a normal distribution and this is of the random numbers which we generated. And we'll fit a line over this to see whether how this line actually behaves. So this line is also a good fit. So the next is comment on the plot from part 4. We can see that the plot is a very good fit to the normal distribution. The Poisson distribution is a good fit to the normal distribution as per the central limit theorem. The lower tail is slightly or heavy. It's a heavy lower tail and it's a lighter upper tail. But the upper tail is a good fit, although the lower tail is slightly has a outlier. Overall, it is a very good fit. Okay. This was the first question. It was very direct. Coming to the second question, an insurance company designed a new product and wanted to assess its client responses to the product. A survey was carried out, giving an opportunity to each participating client to give positive or negative response to the product independently of other clients. Let X be the random variable representing the positive responses to the new product. Identify the distribution of X and its parameters. So the distribution of X is binomial and the parameters are 0, 1. Since the values either can take positive, response can be taken positive or negative. Okay. Then out of 160 clients who responded responded independently to the survey, 101 gave a positive response for the new product. The probability of obtaining a positive response for the product is denoted by theta, and the beta prior distribution with parameters alpha beta is assumed for theta. The posterior distribution of theta is proportional to this, where X is the number of positive responses obtained out of n client surveyed. Specify the posterior distribution of theta with its parameters. So if you see, if you compare this distribution, the posterior distribution of theta is nothing but it's a beta distribution, and with parameters x plus alpha and n minus x plus beta. Okay, very direct, and it's given in the material as well. Comment on the prior distribution of theta in relation to the posterior distribution. Prior is also a beta distribution. Posterior is also a beta distribution. So it's a conjugate prior. Then state the parameter values for which the prior is a uniform 0,1 distribution. So if we have the values as a uniform 0,1 distribution, then the parameter values will become for a uniform 0,1 distribution, the parameter values for prior becomes basically nothing but beta 1,1, so it's a beta distribution which with alpha value with alpha and beta both equals to 1. Okay, so the parameter values are 1,1. So then next part, plot the prior density of theta with parameters obtained in part 4. Set the maximum limit of y-axis to 12. So we have taken x as a sequence of 0 to 1 with a value of 0.01. And then we'll plot x d beta x11. This is the parameter where values which is in part 4. Alpha is equals to 1 and beta is equals to 1. Type equals to says we'll set the y limit to 12 and color is equals to blue. So I'll just set it again, sorry. So this is what I'm getting. Then plot the posterior distribution of theta on the same graph. So for the posterior distribution of theta, since we know the posterior distribution follows this x plus alpha minus 1 and n minus x plus beta, or if where alpha and beta are 1. So x is 101 plus 1 minus 1. So this becomes basically 101. And n minus x plus beta minus 1, n is 160 minus 101 plus beta is 1 minus 1, 1 minus 10, 101 minus 60, basically 160 minus 101 plus 1, so 161 minus, yeah, so this becomes 69. So basically this is 101, sorry, 101 comma 59 when you plot the parameters. Okay, so just plotting it again. So this is what the values will look like. Okay, then we have to use an analyst consulted by the company suggests that based on previous experience, a beta prior with parameters 40,24 is more appropriate. So now alpha beta becomes 40,24. Plot the new prior and posterior distributions. So posterior, again putting in the same formula, we get 141,83. So lines of this again on the same graph, since you need to draw. So I got this on the same graph with different colors and different line types. Okay. And you might want to add a legend, which you can do to this graph as well. Okay. Then comment on the plots obtained in part 5 and 6. Since in part 5 and 6, we see for the first part, the prior was flat with 1,1, and we had got a posterior distribution in green, which was in the shape of a beta distribution. Then for the new prior and posterior distributions are both of the beta, and it consists of the same shape. But again, the prior was a flatter distribution and posterior is a much higher peak distribution, but both have the same shape. Okay. Now the company will put the new product on the market only if there's a high probability that theta is higher than 60%. Calculate the probability that theta is greater than 0.6 in case of both the priors, that is uniforms. So we have to use both the posterior distributions. This was 101,59. Sorry. So 1 minus p beta higher, this is 0.7949 and this is 0.8199189. Okay. Comment on your answer to part 8A. So from the two values, we can see the both values are really close. The probability of both the product in the market is greater than 60% is very high. Okay. So yes, the product can be put to the new market since the probability is very high for both the distributions. Then we have next question 3. This was also a very direct question, not anything much calculations or anything required. Question 3. A male athlete ran 1 mile in 254.4 seconds on 31st May 1913. This was a world record at that time. The data file milerecords.rdata contains the date measured in days since 31st May 1913 and the times in seconds of all new records for males over the 1 mile distance. The data set mile records.rdata contains 32 records. The variables are called record.date and record.time in the rdata file. You can load the file with this. Plot record.time as a function of record.date. So we'll load the files first. So these are the two files we got and display record.date and record.time. I'll plot them as said in the question. Please use main or and whatever axis name you want to. Then you have to calculate the correlations, Pearson correlation coefficient. So correlation of record dot date record, that is a negative, very strong negative correlation. Fit a linear regression model to the data using record dot time as the response variable, record dot z as the only explanatory variable. State the estimated intercept, and so if you this the model where the model is a linear regression with time as the y variable and record dot date as the x variable. And we can also, and we have to specify the, obviously the values of the model. So the coefficients are intercept is this, record dot date is this. This is the value of alpha. This is the value of beta. Plot the regression line by adding it to your plot from part 1. So AB line of model. This will add it to the model. Comment on the relation, perform a statistical test in order to test the null hypothesis that the slope of the regression line is path 0 against a suitable alternative. So this is directly available in the summary of model. So if you run the summary of model, just running the summary of model, if you run that, this is directly available over here that the p-value is less than 0.05, which means that there's sufficient evidence to reject H0, that the slope is not 0. And you can pull this entire value, the original value, using this formula, coefficient of summary of model. Here also you'll get the same answer, that p-value is much less than 0.05, which means we have sufficient evidence to reject H0. Beta is not equal to 0. Comment on the relationship between the two variables. A strong negative relation between the two variables. As the record date increases, the record time is decreasing. Which clearly shows that as you're moving further with dates, contestants are breaking old records every time they want to move forward, which is logical as well. For simplicity, you can assume that 1 year has 365 days. Estimate the expected time in seconds of the world record 100 years after the most recent record in the data set. So new data is a record dot frame. After 100 years means 100 into 365 days we need. This is the new data, and predict model comma new data. So the record is 215.5112. Next part is calculate the number of years from the most recent record in which you expect the world record to be 2 minutes based on your fitted model from part 2. So now you need from fitted model. So we store the coefficient model dollar coefficients of 1, which is alpha, and this is beta. And now we need the value. We know that y has to be 2 minutes. That is 120 seconds. So back calculating 120 seconds means 120 seconds minus the intercept divided by the slope, which will give us the answer for x, which is this value 125241.5. And then the most recent record from our data set is 31448, if you see. So 125241.5 minus this. Sorry. This gives us 256.9684 years. So after 257 years, we will get the record of 2 minutes from the latest record. Okay. Comment on the suitability of linear regression model for modeling record dot time as a record of date. Yeah, it is a very suitable model because as date increases, yeah, or as basically as we are moving further with dates, the record time will decrease, and they will both have a negative relation of always, because people will want to break the records and reduce the record time always. Okay, this was also a very, very direct question, like not at all any kind of you would have to put any extra effort for this. An analyst is asked to produce a report on the existing imbalance in salary in jobs related to science, technology, engineering, and maths. The analyst considers a sample of 100 employees in STEM-related jobs. For each of these employees, information is provided on starting and current salary, gender, type, and job location, the employee's age, and the relevant experience. The data file given is of employed or our data. After loading data into the data frame, data employee with its variable is listed below. So we have got all these variables. Write down the categorical and numerical variables in the data. You can see that salary, current salary, start, age, and experience are numerical data, and all others are categorical data. Plot a scatter graph between each pair of numerical variables using your answer to part 1. So we have 4 numerical variables. So we'll put them together. First, we'll load the data. Once we have loaded the data, these are the categorical variables. Now, the first, second, sixth, and the seventh variable basically are I've put them together with all the rows, and now we'll plot them. So these are the pairs with categorical variables which we have got. Then comment on the relationship between current salary and the remaining numerical variables. So these are the pairs we've got. Now we have to compare these. So here you can see there's a very strong positive relation, that as the starting salary and the current salary will always have a positive relation, because they will increase with time for everyone. And then these have a negative relation as age. This is age and salary current have a negative relation, and very weak negative relation. We cannot exactly say why it's a weak negative, but yeah, with age, the current salary tends to be remaining constant. Okay, and experience has a very, very weak negative correlation with current salary. Okay, it's very weak, so we're not being able to identify that with experience how is the salary current related. Calculate the lower quartile, median, and upper quartile, and the mean for the current yearly salary. So summary of salary dot current will give us all of this: first quartile, median, mean, third quartile together. Okay. Then test whether the proportion of male employees at the current salary below 9.86 is significantly different from the proportion of female salaries with current salary below 9.86. Okay, so you have to test the proportion of male employees and female employees with salary below 9.86. So how we'll use prop dot test. So first we'll have to find out the probability of these male and female. So firstly, I've taken out the male salaries for job for male and then female. Okay. And then you take out the length of the male salaries which are greater than 9.86, and then female salaries which are greater than 9.86. Then the length of all of these, and X is basically a combination of these two. I'll just run all of these together because it's creating a problem. And then X is C and N is of C is equals to N1 comma N2, and L is the proportion C bind of X comma N minus X. Okay. And here we have that both proportions are same and both proportions are significantly different. Use a prop dot test, testing L, where alternative is equals to two-sided Okay. So here when we have prop dot test is equal to two-sided, we have that p-value is less than 0.05, and therefore we have sufficient evidence to reject H naught, that proportions are same, hence proportions differ significantly. Okay. Determine the median, mean, and variance of the current yearly salary for each of the job types. So there are 5 types of jobs. So for each of these, I have taken a C and I have written, just extending this. So with the C, mean of salary current job type is equals to 1, median and variance of this. Similarly for job type 2, 3, 4, 5, we just change. Copy paste it and just change the variables. Okay. And I can run it all together to get all my answers. Okay. These are all the answers. So job type 1, job type 2, job type 3, 4 and 5. Okay. Now test at the 5% level, the mean starting salary and the mean current salary are significantly different. So start salary and current salary are significantly different. So we have used a T dot test with salary dot start and salary dot current, with variance is equals to true assuming and confidence level at 95%. So this is giving us an answer of p-value again less than 0.05. So we have significant evidence to reject H naught, that the mean salary of mean of starting salary and current salary is not same. Then we have test at the 5% level whether the mean current salary for the big city employees is greater than the mean current salary for small city employees. So H naught is mean current salary for big city is equal, and H1 is it is greater. Okay. Then we have a T dot test again where salary location job is equal to 0 is big city, 1 is small city, and your alternative is equals to greater. This is, sorry, alternative is greater because these are greater, and then we just run this. So we have again a p-value, which is so true difference in mean is greater than 0. That means big city minus small city is positive, or big city is greater than small city. Okay, you can just check your alternative hypothesis using this sentence. Again, we have a p-value which is much less than 0.05. So we have significant evidence to reject H naught, and we can accept that yes, the mean current salary for big cities is greater than the mean current salary was small cities. That was all about CS1 paper B. It was a very, very direct paper this time. There were no questions which were tricky or which could not have been plotted. Okay, thank you.